Hello and welcome back to our discussion and demonstration of topographic maps. We'll be talking about the Universal Transverse Mercator System, or UTM grid. We'll cover the concept of northings and eastings, and then just simply reading UTM on maps. Later on, I'll show you how it's a useful type of grid for measuring distances, or at least especially when there's not a map scale that's available and for us to use. The grid system is set up in such a way that we use very regular and practical units. Instead of degrees, minutes, and seconds, we're going to use and make measurements in meters. In some cases, kilometers if you would prefer, but in most map scales, we're interested in measuring things in the units of meters and simply meters of distance on the grid. And so the Earth has been cut up into a series of zones, UTM zones. And you can see those on the map on the top left-hand side here, where you've got Zone 10, Zone 11, Zone 12. So you need to know what zone you're in, because for every zone, the meter count resets, right? So you could have an eastern measurement easting measurement from the west to the east here, let's say 300,000 meters. Well, 300,000 meters in zone 12 is not in the same position as it is in 13. 300,000 meters in 13 would be over here, and we'd say that's 300,000 meters east. The same could be said for northing and for northings as well, where we're measuring top to bottom. But it turns out, if we come over to the right hand side, that our grid boundary, it stops east to west short at about 6 degrees of longitude, but top to bottom for latitude, it goes from the South Pole all the way to the North Pole. So we're reading a measurement from the South Pole to the North Pole that's measured in millions of meters typically. So this is, for instance, 10,000 kilometers up here, and this is 0 kilometers down at the equator. So if we change this into meters, it becomes 1, 0, 0, 0, 0, and then if we want to change it into meters, we have to 1, 2, 3. So it's 10 million meters in that direction. East to west, we don't cover that same amount of distance, and so we only need hundreds of thousands of meters in the system. Okay? So here we have a map. It's a 7.5-minute series of Wyoming and Montana. It's a topographic map, and we'll see some units that we haven't seen before and some that we have. In the top right-hand corner here, we see that we've got a familiar set of measurements. We've got our longitude line at 110 degrees, 45 minutes and 0 seconds, and then our latitude line down here at 45 degrees, 0 minutes to the north. These are not useful for this grid system, but they are both put onto the same maps. Our measurements for UTM are written in this way, and they're part of a grid system that's usually drawn like straight onto the map. So you'll notice that the things I'm highlighting, 517, 518, 519, or what is 4982 and 4981, they have a subscript and then a regular size script, or a smaller script in front. And so these are abbreviated measurements. Really, these are the measurements we want, and just like latitude and longitude, we're using a grid to locate a point, and also we're going to be adding meters on and doing that in the same way that we use latitude and longitude. However, in this case, we need these are abbreviated, so I need to write this out. This actually needs to have 1, 2, 3 zeros added to it. So in this case, it's 5170. So it's 517,000 meters, and now we know it's 17, 18. So it's to the east. It's getting bigger. So that line is an easting of 517,000 meters. Now, if we come over to the right-hand side, okay, we're measuring North Pole to South Pole, so we're measuring a larger distance. We need more meters, and so this is 49,000. sorry, not 49,000. We're going to add 3 zeros to this. 1, 2, 3. Right? So this becomes 4,982,000 meters. So this is 4,982,000 meters to the north. All right? So that's how you read it. This one down here is we're going to add 3 zeros. It's going to be 4,981,000 meters to the north. So if this one is 517,000, this one here should be 518,000. That means that this distance east to west, or in this case north to south, okay, is 1,000 meters, or 1 kilometer. Okay, 1,000 meters. So let's say I had a location I wanted to sort of precisely measure the location of something. We'll do this in a more accurate way in a little bit, but I'll just put an X here, roughly where I want to be. I know that it sits here between 518 and 519 in terms of the east to west measurement, and it sits between 4981 and 4982 in the north to south measurement. So as with any grid system like this, you want to start out with this first number, 518000, and you want to add in a certain number to it to make it a bigger number, of course. So we got 5180. We're going to add one more zero on there. Okay. So the question is, from this line to this point, what's that distance? Well, we are going to measure it more precisely later, but it's about 500 meters, right? And then from this line, 4981, or 4,981,000 meters, we're going to measure north. And how long is that? Well, it's probably somewhere around 400 meters. And so this X is at 4,981,400. So we just took that 400 and added it into this value here. Okay, and this one on the top here is 5180000. So that means it's going to be over here 518, and then we're going to add 500 meters to it, 500 to the east, and this is to the north. 518 500. Okay, so the easting and the westing are the two components you need for every measurement of on a UTM grid. You would also need to note the zone that you're in. So zone 13, zone 14 that I showed you on the previous map. But usually that's just written on your map somewhere. For the map I'm showing you here, I'm showing you a snippet of the map, and it would be written somewhere down on the southern part of the page. Okay, so that concludes my summary of how to read UTM grid and how big the grid is in terms of its scale. You'll want to note that it's 1 kilometer by 1 kilometer on the grid. It's going to be very useful in the